Quick headlines before the intro. Governments can restrict chip exports, but compute is not only a box crossing a border. It is also rented capacity, idle hardware, cloud regions, and distributed GPU networks. The real question is whether decentralized compute makes AI infrastructure harder to govern.
Powered by artificial intelligence.
Export controls are designed to restrict access to advanced computing semiconductors and certain supercomputing uses. They target shipments, entities, and controlled performance thresholds. That can slow direct access to top-tier hardware, but it does not erase global demand for compute. Decentralized compute networks try to turn scattered hardware into a marketplace. A gaming GPU, workstation, or small data center node can become rentable capacity. This is not a drop-in replacement for a hyperscale training cluster, but it can support inference, rendering, fine-tuning, batch work, and smaller jobs. The hard parts are latency, reliability, privacy, and compliance. Training a frontier model requires dense interconnects, synchronized hardware, and predictable uptime. A distributed market can be powerful, but it has to prove workload integrity, data protection, payment reliability, and lawful use. Policy gets harder when compute is virtualized. A GPU may sit in one country, a buyer in another, data in a third, and payment through a fourth. That does not make controls obsolete. It forces regulators to think beyond boxes and toward access, identity, end use, and cloud services. Bottom line, decentralized compute is not yet a borderless supercomputer that cancels export controls. But it is a pressure valve that makes compute more liquid. The silicon border is becoming less about hardware alone and more about who can access intelligence at runtime.